When NASA's Curiosity rover transmitted these images back to Earth, the internet immediately erupted. Staring back from the Martian dirt was a repeating, geometric texture that looked like the frozen, fossilized scales of a massive reptile. The discovery was an accident. Curiosity was rolling through Gale Crater on a routine drive when it crossed over this deeply textured terrain. When the raw images hit the public database, millions of people asked the exact same question. Are we looking at the physical remains of an alien organism? While the immediate instinct is to imagine a dormant creature beneath the sand, we are looking at a deeply physical anomaly carved right into the bedrock. Our brains are biologically wired to find familiar shapes in random noise, especially when we look at the blurry, distant landscapes of another planet. We saw this 30 years ago when a probe snapped a photo of a mesa that looked like a human face staring up from the surface, and again when rovers photographed rocks shaped like floating spoons. High-resolution cameras eventually proved those shapes were illusions, visual tricks created by wind erosion, casting highly specific shadows at certain times of day. But this scaly texture in Gale Crater is a solid, repeating structure, physically etched into the terrain, and it demands a strict scientific explanation. To a geologist, those scales are instantly recognizable as fossilized mud cracks. Finding them perfectly preserved tells us that billions of years ago, this specific region of Mars experienced highly regular, repeating cycles of wet and dry seasons. Imagine a landscape where rivers flowed, rain fell, and lakes repeatedly swelled over the land, only to evaporate back into a desert over millennia. Every time the water receded, the mud shrank and fractured. As the cycle repeated, those fractures deepened, forcing the ground into highly organized, hexagonal shapes before eventually freezing into stone. These geometric scales are a physical memory, hard evidence of an active, water-rich climate that sustained itself over vast stretches of time. In astrobiology, there is a rigid rule. Wherever you find a stable history of liquid water, you find a realistic environment for life to take hold. And right as Curiosity was confirming that ancient water cycle, another NASA rover called Perseverance was exploring an entirely different impact crater on the other side of the planet. Perseverance found a series of peculiar rocks covered in tiny, distinct rings, structures the science team quickly labeled leopard spots. On Earth, these exact types of spots are created by ancient microbial life. As microscopic organisms consume minerals for energy, they leave behind concentrated, localized chemical signatures locked inside the stone. The scaly mud cracks in Gale Crater proved the Martian surface was highly hospitable. These spotted rocks offer physical traces of what might have actually lived in that water. Between these two discoveries, NASA now has both a proven habitat and chemical biosignatures that strongly match organic biology. But right now, we are stuck analyzing these physical anomalies using small robotic laboratories millions of miles from home. To get definitive answers, NASA and the European Space Agency are orchestrating the Mars sample return. The sole objective of this massive operation is to physically drill into the exact pieces of rock containing those mud cracks and leopard spots, pack them into an ascent vehicle, and launch them back to our planet. The long era of squinting through camera lenses is coming to a close. Within the next decade, researchers will be holding literal pieces of the Martian surface in their hands. Once those Martian rock samples reach the most powerful electron microscopes inside terrestrial laboratories, the scientific stakes become absolutely enormous. If researchers can confirm the existence of even one fossilized microbial cell within those rocks, our understanding of biology across the cosmos instantly expands. We will finally have to answer the question: were we ever truly alone in the universe? To follow the Mars sample return mission and see the actual results when they land, hit the subscribe button below. And if you want to see what else we're finding out there in the dark, click the video on your screen right now.